is Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Okay. Today our topic is Laplace transform periodic functions, and the continuation of the topic is inverse Laplace transform basic concepts. Okay, Laplace transform periodic functions as the last topic in the Laplace transform. Already we discussed in the previous classes Laplace transform basic concepts, the properties and integration of that, first shifting theorem, second shifting theorem, derivatives, integration, all topics we discussed in the previous classes. Now today we discuss the last topic, that is periodic functions. Okay, and the last and after the periodic function, then the next topic is inverse Laplace transform. That is completely converse of the Laplace transformation. First we discussed about the periodic function, transform of periodic functions. Okay, here definition for the periodic function is a function f of x is said to be periodic if and only if f of x plus p is equal to f of x is true for all some values of p and every value of x. Okay, here what is the definition of that? A function f of x is said to be periodic when it is periodic if and only if f of x plus p is equal to, if you have taken any period value of p, again we got the same function f of x is true for some values of p and every value of x. Here what is p? That is the smallest positive value for which this equation is true for every value of x will be called the periodic function of the function, period of the function. Once again I'll repeat here, what is periodic? Periodic means f of x plus p is equal to f of x. If you are taken any value of p, if you have taken any value of p, okay, then the function is, for example here the function is f of x is equal to sin x. We are substituting in the period of p, we got the same function f of x, that is called as the periodic function. When we got the same function after applying the periodic function formula, for example, let us take here p is equal to 2 pi. Okay, here the first example, f of x is equal to sin x. I'll test in the period of 2 pi, again we got the same function or not. Okay, here what is the definition of the periodic function? F of x plus p is equal to f of x. Now I'll substitute, that is sine of function is sin x, sine of x plus 2 pi. Sine of x plus 2 pi, that is equal to sine of 2 pi plus x. Sine 360 degrees plus x. Sine 360 degrees plus x means, what is the value of this? What is the value of this? This is equal to, again we got the same function sin x. If you have taken any period value, I'm taking here 2 pi, for that case we got the same function. What we take the function here sin x, after applying the formula also we got the same function, that has sin x. Okay, therefore here sin x as a periodic function. I'll repeat one more here. For example, here the same function sin x and I'm taking p is equal to 4 pi. I'm applying again, but I'm taking the different value of the p, that is the period is equal to 4 pi. Now I'll test, is it periodic function or not. Okay, sin x plus 4 pi, sin x plus 4 pi. What is p here? 4 pi. Then sin of 4 pi plus x. At as p is equal to 4 pi also, sin as the periodic function, we got the same function, that is sin x. If you have taken at p is equal to 4 pi also, we got the same function, that is sin x. Let us test one more here. Here I'll take third one. If I'm taking f of x is equal to, again I'll take sin x, and that period is equal to, I'm taking 6 pi. This period is equal to 6 pi. I'll test, is it periodic function or not at the particular value of 6 pi. That is sine of p, that is 6 pi plus x. Sine 6 pi plus x. For that case also, we got the same function, that is sine x. Sine x. That means this is also periodic function at the particular value of 6 pi. That means what we observed, the particular value of 2 pi, 4 pi, 6 pi, for that all cases we got the same function, that is sine x. Therefore, sine x is a periodic function. Okay, that is sine x is a periodic function. That means at 2 pi, 4 pi, and 6 pi and so on. In that all cases, sin x is a periodic function. Okay, I'll give one more example for the periodic function. Okay, I'll take here f of x is equal to cos x. Okay, is it periodic function or not? I'll check it. Okay, f of x is equal to cos x. Let us assume I'll take p is equal to 2 pi. Okay, what is the definition of the periodic function here? F of x plus p is equal to f of x. Then f of x, that is f of x is equal to cos x. After applying the periodic function formula, that is sin x, I'm sorry, here cos x plus p. But what is cos period is x plus 2 pi. Cos x plus 2 pi. Once you observe here 2 pi plus x, in that cos 360 plus x also, in that case cos 360 plus x means for that case we got the same function, that is cos x. If you have taken period p is equal to 2 pi, okay, for that case cos x is repeated. Therefore, cos x is also a periodic function. Okay, I'll take one more example for the same function. I'll check it as with respect to 4 pi. Okay, in that case the cos x is periodic function or not. Okay, for that case cos of 4 pi plus x, cos of 4 pi plus x, for that case also cos x. Okay, therefore, and similarly at p is equal to 6 pi also cos x as the periodic function. What we observed in the two examples, that means in the cos x and sin x, both are periodic functions at x is equal to 2 pi, 4 pi, 2 pi, 4 pi, and so on up to. For that case, the two are periodic functions. Okay. Next, I'll take one more example. Okay, I'll check it with respect to p is equal to pi. Okay, one more example, that is tan x. Tan x is periodic or not? Okay, I'll check. That is tan x, tan of, I'll take p is equal to pi. P is equal to pi. For that case, tan x is periodic function or not? I'll check that as, that is p plus x, that is tan of periodic is 180 plus x, that is tan pi plus x. Okay, at the case of tan pi plus x, that means 180 degrees plus x. For that case, we got the same function, tan x. Okay, that is tan x. If you have taken p is equal to pi, for that case f of x is equal to tan x. And I'll take one more example with respect to the f of x is equal to cot x. I'll check the same period here. P is equal to pi. Okay. For that case, cot of P plus X, cot this is, that is cot of pi plus X. For that case, what we got? Cot of 180 plus X. That case, we got again cot X. That means if you are taken P is equal to pi, okay, for the function tan X and cot X, the two are periodic functions. The two are periodic functions. What we observe at the particular value of, at the particular period of pi, for that case tan X and cot X are periodic functions. What about P is equal to minus pi? What? No need to take P as minus pi. Why? Because here, what is the condition for the P? P is the smallest positive value of P. For this, equation is true for every value of X. For that case only, the function is periodic. Now, I'll apply the periodic formula on the Laplace transformation. Okay, that is the Laplace transform of a periodic function f of t with the period p. Okay, f of t with the period p is given by, for the periodic function for the Laplace transformation. For that case, what is the formula? 1 by 1 minus e power minus ps integral 0 to p e power minus st into f of t dt. This is the Laplace transformation periodic function formula. Okay. Now I'll explain the related questions. Okay, problems based on Laplace transform of periodic function. Laplace transform of periodic function. What's the first question here? Find the Laplace transform of the half sine wave rectifier function. Okay, what is the question here? Half sine wave rectifier function. That means what's the given function form? F of t is equal to, if the t value is in between 0 to pi by w or omega, for that case the function is sine omega of t, or generally we can consider that as sine wt also. Okay, and next, if the interval is in between pi by w less than of t less than 2 pi by w, for that case that value is equal to 0. What they are given in the function form? F of t is in between 0 to pi by w, that is sine w of t, and in between pi by w to 2 pi by w, okay, that is the value in between t. For that case function is 0. Okay, for that case now I'm applying periodic function for this problem. What is the definition of the periodic function? That is Laplace of, okay, what is the formula of that? Laplace of 1 by 1 minus formula e power minus ps integral of 0 to p e power minus st into f of t dt. This is the Laplace transform periodic function formula. Periodic function formula. Okay, now I'm applying the formula for the given question. That is, what is the given question here? Laplace of f of t is equal to, f of t is a given function. I'm applying the transformation formula on this function. How to apply here? That the period is here, that the period is completely 1 by 1 minus, that means from the question 0 to the period is up to 2 pi by w. Okay, right here the period is how much? Period p is equal to 2 pi by w from the given question. Okay, therefore from the given question, that is 1 minus e power minus 2 pi by w into s integral 0 to 2 pi by w 2 pi by w e power minus st into f of t dt. Okay, f of t into dt. Once you observe here, the limit values are 0 to 2 pi by w. Okay, 0 to 2 pi by w. For that case, what is the function from the given question? Exactly, there is no function within the interval 0 to 2 pi by w. For that case, how to divide the interval is 0 to pi by 2 pi by w and pi by w to 2 pi by w. Okay, now I'll divide the interval values here. That is 1 by 1 minus e power minus 2 pi s by w and 0 to pi by w e power minus st into f of t dt plus the next one here, pi by integration of within the limits pi by w to 2 pi by w and e power minus st into f of t dt. Okay, there is no exact function within the interval 0 to 2 pi by w in the given question. That's why I'll divide the limit values according to the question, that is 0 to pi by w e power minus st to f of t dt plus pi by w to 2 pi by w integration of, that is e power minus st into f of t dt. Okay, then I'll substitute that corresponding function, that is 1 minus e power minus 2 pi s by w integral 0 to pi by w e power minus st into, what is the function here within the interval 0 to pi by w? That is sine wt. That is sine wt dt plus integration of pi by w 2 pi by w e power minus st into, what is f of t here? Once you observe the given question, pi by w to 2 pi by w, that is 0. 0 into dt. That is 0 into dt. Therefore, after this, that means after substituting the functions here, the second part is completely 0. After this step is here, that is 1 by 1 minus e power minus 2 pi s by w integration of 0 to pi by w e power minus st into sine wt dt. The second part as 0. Okay, next. Once you observe, after substituting the functions and the second term as 0 and the first term, which is in the form of what? Which is in the form of what? Which is in the form of integral a to b e power ax into sine bx dx formula. Okay, which is in the form of integral, okay, integral a to b e power ax into sine bx dx. Not integral a to b, integration of e power ax into sine bx dx. What is the formula for that? Then that is equal to, what is the formula for that? E power ax by a square plus b square into a sine bx minus b cos bx. Now I am applying this formula for the above step, which is in the form of integral of e power ax into sine bx. E power ax into sine bx. Once you observe, after substituting here what is a from the above step? In the above step, a is equal to minus s. Okay, that means e power ax by a square plus b square. A is here minus s, and what is b here? W. What is b here? W. That is here 1 by 1 minus e power minus 2 pi s by w. Take it outside and the remaining as substitute the formula. That is e power ax. What is a here? Minus s into t by a square plus b square. What is a here? S. And what is b here? W. Into a sine bx. A means minus s and sine bx. That means b as w. That is sine w t minus w. That is b cos bx. What is b here? W into cos bx. That is cos of w t. Okay, after substituting the formula, then substitute the limit points. What are the limit points after applying the formula here? The limit points are 0 to pi by w. 0 to pi by w. Now I am substituting the limit points here. That is 1 by 1 minus e power minus 2 pi s by w into here the first limit point, here the integration with respect to t, that means here you have to substitute the limits in terms of t only. In place of t, that is e power minus s into pi by w by s square plus w square minus s into sine w of pi by w minus w of cos w of pi by w. If you are substituting the upper point, that is pi by w, we got this first part, and minus of, I'll write this step here, that is e power minus s of 0 by s square plus w square into minus s sine w of 0 minus w of cos w of 0. Okay, this is after substituting the limit points, upper limit as pi by w and the lower limit as 0. Therefore, for that case, okay, here 1 by 1 minus e power minus 2 pi s by w into here w cancel and there also w cancel. For that, here once you observe sine pi value how much? Sine pi as 0. Sine pi as 0. And what about minus of cos w? That means cos pi value. That is minus 1. Okay, here, I'm sorry. Directly I'm explaining here. That is 1 by 1 minus e power minus 2 pi s by w, that is e power minus s pi by w, and here sine pi as 0, that is 0, minus double into cos pi as minus 1, that is minus 1. And the next continuation, minus of e power 0 alias 1 by s square plus w square, here sine 0, 0. Sine 0, 0. And what about the cos 0 here? Cos 0 as 1. That is minus w of cos 0 as 1. That is minus w of 1. For that we got 1 minus here e power minus s pi by w by s square plus y square, that is 1 by 1 minus e power minus 2 pi s by w, that is e power minus s pi by w by s square plus w square into minus plus, that is w, plus s square 1 by s square plus w square into minus plus, that is w. Okay, for that step here, what is common? What is common here? The denominator is common, that is s square plus w square, and the remaining part after this step, this one, that is 1 by 1 minus e power minus 2 pi s by w, and here LCM, that is the common term of the denominator, that is s square plus w square, and the remaining part numerator e power minus s by is w into w plus w. Here what is common after that? W is common. W is common, that is w into 1 plus e power minus s pi by w divided by 1 minus, once you observe here, this is 1 minus e power minus 2 pi s by w. That means which is in the form of what? A square minus b square. A square minus b square. If you are interested, you can divide that. Otherwise, directly write down. That means I'll divide here a minus b into a plus b, and here the denominator as s square plus w square. Therefore, here once you see here, After dividing the denominator, which is in the form of a square minus b square, once you observe here, 1 plus e power of minus s by w and 1 plus e power minus pi s by w, both are cancelled. Both are cancelled. Okay, therefore what is the final answer for that? W by 1 minus e power minus pi s by w into s square plus w square. Okay, therefore Laplace of, where we have to find at sin w t value, w by s square plus w square into 1 minus e power of minus pi s by w. This is the final answer for applying the periodic function formula in the Laplace transformation. Okay, this is the last topic and one question only is there in the textbook. Okay, next I'll continue the next topic as inverse Laplace transformation. Okay, inverse Laplace transformation. What is the inverse Laplace transform? It is completely converse of the Laplace transformation. Okay, it is completely converse of the Laplace transformation. Already we discussed in the previous classes what is Laplace transform and where we applied inverse. Okay, what is the difference between inverse Laplace transformation and the Laplace transform? Now I am giving direct definition for the inverse Laplace transformation. Simple hint for that, this is the converse of the inverse Laplace transformation. Okay, that is if Laplace of f of t is equal to f of s. Previously, we can consider Laplace of f of s is equal to f of t, but here the converse is if Laplace of f of t is equal to f of s, then the converse is Laplace inverse of f of s is equal to f of t. In that Laplace, how to define the function? Laplace of f of t is equal to f of s, that the converse is inverse, that is Laplace inverse of transformation is s to t, that is f of s is equal to f of t, where Laplace inverse is called the inverse Laplace transformation operator, that is inverse Laplace transformation operator. Here one property is also there, previously we discussed this one also. This is the linear property of the inverse Laplace transform. Directly I am giving the statement for the inverse Laplace transformation. If f1 of s and f2 of s are the Laplace transforms of f of t and g of t respectively, then what is the linear property for the inverse Laplace transformation? That is Laplace inverse of c1 f1 of s plus c2 f2 of s is equal to c1 into Laplace inverse of f1 of s plus c2 into Laplace inverse of f2 of s. Okay, this is the linear property and that particular definition of the inverse Laplace transform. The next one, okay, next we will discuss inverse Laplace transform basic formulas. Basic formulas. Already we discussed this type of formulas in the Laplace transformation. What we discussed again here, this is the converse of the Laplace transformation. Okay, important formulas. That is first formula, Laplace inverse of 1 by s is equal to 1. Laplace inverse of 1 by s is equal to 1. Previously, okay, in the Laplace transformation, Laplace of 1 is equal to how much? That is 1 by s. That is Laplace of 1 is equal to 1 by s. The converse here, Laplace inverse of 1 by s is equal to 1. In the second definition, that is second formula here, Laplace inverse of 1 by s power n. 1 by s power n. What is the formula for that? That is t power n minus 1 by n minus 1 factorial. T power n minus 1 by n minus 1 factorial. This is n minus 1 factorial. And the next third formula, Laplace inverse of 1 by s minus a, that is equal to e power at. Already we know that this is the same formula in the Laplace transform, that is Laplace of e power at is equal to 1 by s minus a. Okay, this is converse. That means Laplace inverse of 1 by s minus a is equal to what? Here e power at. Next, fourth formula here, Laplace inverse of s by s square minus a square. Here s by s square minus a square, for that case formula cos h at. And the next one, Laplace inverse of 1 by s square minus a square. Laplace inverse of 1 by s square minus a square. That formula is 1 by a into sin h a t. Here what is a? This is a. Okay, for that 1 by s square minus a square into, just by heart it, that is 1 by a into, the denominator is in negative, s square minus a square. That case we have to take the function as sin h a t. Sin h a t. And the sixth formula here, Laplace inverse of 1 by s square plus a square. Laplace inverse of 1 by s square plus a square. Once you observe, that formula is 1 by a into sin a t. Here a has what we have taken the a value, then we have to write that as 1 by a into sin a. But what is the difference between these two? Here the denominator as in negative, here the denominator as in positive. If the denominator is in negative, then we can take the function as an hyperbola, that is sin h of at. Here the denominator is in the positive, then that case we have to take that as sin at. Next, seventh formula, Laplace inverse of s by s square plus a square. S by s square plus a square. For that case, formula as cos at. For that case, the formula as cos at. And the next eighth formula, Laplace inverse of f of s minus a. Okay, this is also there in the Laplace transformation. Once you observe, it is also same as first shifting theorem. Okay, neglected Laplace inverse. If you are taking f of s minus a form, for that case we are using exponential of that. If the function is an exponential, in case we have to take that Laplace transformation. That converse is here. If the function is in s minus a form, for that case formula e power at into f of t. E power at into f of t. Next, ninth one, Laplace inverse of 1 by s minus a whole square plus b square. Okay, here s minus a whole square plus b square, for that case formula 1 by b into 1 by b into e power at into sin bt. This is a and this is b. And the 10th formula, Laplace inverse of s minus a by s minus a whole square plus b square. For that case formula, e power at into cos bt. E power at into cos bt. And the 11th formula, Laplace inverse of 1 by s minus a whole square minus b square. For that case formula, 1 by b into e power at into hyperbolic formula, that is sin hbt. Sin hbt. Okay, these are the, okay, next 12th formula, Laplace inverse of s minus a by s minus a whole square minus b square, that is e power at into cos hbt. Okay, next 13th formula, Laplace inverse of s by s square plus a square whole square, that is equal to 1 by 2a into t sin at. Next, Laplace inverse of s square by s square plus a square whole square. For that case formula 1 by 2a into sin at plus at into cos at. Sin at plus at into cos at. And the 15th formula, Laplace inverse of 1 by s square plus a square whole square. For that case 1 by 2a cube into sin at minus at into cos at. And the 16th formula, Laplace inverse of s square minus a square by s square minus a square by s square plus a square whole square. S square plus a square whole square. For the case formula, t into cos at. t into cos 80. And the last formula here, that is Laplace inverse of 1. Laplace inverse of 1 is equal to delta t. Okay, these are very important problems. If you know the formulas only, easily you got the answers for the inverse Laplace transform problems. Okay, next. Okay, now I'll explain these related problems. Then the first question, problems based on inverse Laplace transform. Okay, first question, find Laplace inverse of 2s by s square minus 16. This is very simple question. If you know the above formulas, directly we got the answer for this question. What is the formula for this given question? Once you observe here, what is the function? 2s by s square minus 16. Okay, 2s by s square minus 16. I'll take 2 outside here. That is 2 outside. Then Laplace inverse of s by s square minus 16. I'll write this as 2 into Laplace inverse of s by s square minus 4 square. Okay, that is, once you observe which formula is useful for this, s by s square, s by s square minus s square. That is, I'll write here Laplace inverse of s by s square minus s square is equal to what? Cos h in t. Using this formula for this given question, that is Laplace inverse of s by s square minus s square is equal to what? Cos h a t. For the given question here, what is a? A is equal to 4. Okay, therefore the final answer 2 already is there, that is cos h 4t. 2 cos h 4t. Therefore, Laplace inverse of 2s by s square minus 16 value is 2 cos h 4t. Okay, this is the first question. Again, I'll go through the second one. That is, find Laplace inverse of s minus 3 by s square plus 4s plus 13. S minus 3 by s square plus 4s plus 13. That is, I'll write this as simply Laplace inverse of s minus 3 by, okay, here I'll write this Laplace inverse of s minus 3 by s square plus 4, okay, plus 9 plus 4. Okay, I'll write like this. That is s square, okay, Laplace inverse of, how I'll write that denominator part here, I'll divide 13 as 9 plus 4. Okay, 9 plus 4 means how much? 13. Or otherwise simply add and subtracting with 4 also. Okay, add and subtracting with 4 also correct, or directly divide 13 as 9 plus 4. Okay, then Laplace inverse of s minus 3 by s minus 3 by, which is in the form of a square plus 2ab plus b square. A square plus 2ab plus b square. That is, yeah, that is s plus 2 whole square plus 9. This is this one. Okay. Then next I'll write minus 3 as numerator part, Laplace inverse of s plus 2 minus 5. 2 minus 5 how much? That is also minus 3. Why I am writing like this here? Once you observe the denominator which is in the form of s plus 2 form, that's why I'll convert the numerator as also in terms of s plus 2. That is Laplace inverse of s plus 2 minus 5 by s plus 2 whole square plus 9. That is, okay, then I'll write that as Laplace inverse of s plus 2 by s plus 2 whole square plus 3 square minus 9, I'll write it as 3 square, minus 5 into Laplace inverse of 1 by s plus 2 whole square plus 3 square. Okay, then after this, once you observe here numerator and denominator which is in the form of Laplace inverse of s plus a, that is Laplace inverse of f bar of s minus a formula. Okay, once you observe the formulas here, eighth formula, Laplace inverse of f of s minus a means what? Laplace inverse of f bar of s minus a is equal to e power a t into f of t. But here, the given question here, what is the form of this? Sorry. Laplace inverse of f of s minus a is equal to e power a t into f of t. Okay, this is the eighth formula, but I am applying this formula here. Once you observe here, the numerator has s plus a form. That means Laplace inverse of similarly s plus a is equal to what? E power minus a t into f of t. This is the eighth formula. Applying eighth formula, which is in the form of s minus a. For that case, exponential is positive. That is e power a t into f of t. Yeah, that's why here the question has s plus a form. For that case, exponential as e power minus a t into f of t. Then apply that formula here. That is here a has 2. That is e power minus 2t into Laplace inverse of s by s square plus 3 square minus 5 by. Okay, here for the second part, I'm multiplying and dividing with 3. That is 5 by 3 into Laplace inverse of 3 by s plus 2 whole square plus 3 square. 3 by s plus 2 whole square plus 3 square. That is e power minus 2t into, after applying the eighth formula, it will convert e power minus 2t into Laplace inverse of s by s square plus 3 square. What is the formula for that? Cos 3t. That is e power minus 2t into cos 3t minus 5 by 3 into here what is the form of that, which is also in the same of f power of s plus a. Okay, that's why I'll write here e power minus 2t into Laplace inverse of 3 by s square plus 3 square. After applying the eighth formula here, s plus 2 will be converted as s square plus 3 square. Therefore, the final answer here e power minus 2t into cos 3t minus 5 by 3 into e power minus 2t Laplace inverse of 3 by s square plus 3 square. What is the formula of that? Which is in the form of Laplace inverse of a by s square plus a square. That is sin at. Sin at. Therefore, the second question answer is Laplace inverse of s minus 3 by s square plus 4s plus 13 is equal to e power minus 2t into cos 3t minus 5 by 3 into e power minus 2t into sin 3t. These are the examples for the inverse Laplace transform. Next class, we will discuss these all related inverse Laplace transform all topics in the next session. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.